Today's problem is trail of ones. Difficulty is medium. Given an integer n, the task is to count the number of binary strings of length n that contain at least one pair of consecutive ones. Binary string is a sequence made up of only zeros and ones. Okay. Let's look at constraints. Between n is between 2 and 30. Okay. Expected complexity. Linear. You see this. Okay. Company tags. Amazon likes this. Bit magic. Dynamic programming. I guess so. We're not really going to do any bit magic, but dynamic programming, I guess. I mean, we would build up the solution to larger problems based on smaller problems. So that's probably accurate. Well, let's take a look at this. Look at whoa, hold on. Sorry, trying to find the pen here. Okay, here it is. Well, let me see if I can get this. Okay, yes. Oh no, wait. No, before we start writing, I got to do something here. All right. Well, all right. So if n equals 2, there are 4 strings, 4 binary strings of length 2. Here they are: 0, 0, 0, 1, 1, 0, 1, 1. How many have consecutive ones? Only one string. Now, if n is 3, there's more strings, and of the 8 strings of length 3, 3 of them have consecutive ones. Now, if n goes to 5, there are going to be 19 strings having at least one pair of consecutive ones. I wanted to illustrate something here that's useful sometimes. I think it's useful in this problem. And that is, you can write really any code at all here, return 0, and run test cases. So custom input. Why is it coming up like that? Why is it coming up like that? Kind of strange. Can I scroll this? Can I scroll it like this? No, it still doesn't help. Hang on. Custom input. No, I don't know why it comes up like that. Let me compile and run it, see what happens. Okay, that's better. Case 1. It's wrong. And 2, okay, yeah. But it's useful, custom input. What if you wanted, larger numbers? 5. What if you wanted maybe 6? What would be the answer for 6? Right? And then what would be the answer for 7? Right? Then we can run it again. It'll still be wrong, but it'll tell you what the correct answer is. Okay, for 6, it should be 43. For 7, oh, wait a minute. Why is it not showing me the answer for 7? Hang on. For 6, for 7, it should be 94. All right, good. Now we can start, writing down the patterns here, or the results, and see if we can detect a pattern. So for input of 2, the answer was 1. For an input of 3, they told us the answer was 3. For 4, they didn't tell us, but it turns out that the answer is 8. Right? For 5, they did tell us. For 5, it was 19. Okay, now we just ran 6 and 7, so 6 was 43. 7 is what? 94. 8, I already ran 8, so I can tell you that it is 201. All right, is there any pattern here? Well, from 1 to 3, we could double this, double the 1, and then add 1 and get 3. Now, from 3 to 8, we could double the 3 and add 2 and get 8. Here, we could double the 8 and add 3 and get 19. We could double the 19. Oh, well, wait a minute. Actually, let me write down what we're adding. We're going to double and add 1. We're going to double and add 2. We're going to double and add 3. We're going to double this, 38. Oh, now we have to add 5. All right. What about this? 43, we double it, 86. Okay, so now we have to add 8. If we double this, we get 188. Now we have to add 13. Okay, so here, there's the pattern, is we're doubling the previous number, and we're adding Fibonacci numbers, 1, 2, 3, 5, 8, 13, etc. Okay, so let's see if we could, let's see if we could implement that. Turn this off, remove this. All right, hang on a second. All right, so given that if n equals 2, the answer is 1. Now we'll initialize some variables. Answer is 1. So our initial answer, A is 0, B is 1. We're starting a Fibonacci sequence here. And then if I is anything greater than 2, then, and you can maintain the Fibonacci sequence any way that you want to, but in this case, we'll get the next number in the sequence by adding A and B, and we'll keep track of the previous 2 numbers by sliding B over to A and sliding C over to B, and then multiply times 2, add the Fibonacci number, and continue in that fashion. Double it, add the Fibonacci number. Just keep track of a Fibonacci sequence as we go here. And let's try that. Oh, wait a minute. That's not what I wanted to do. It's still running test cases. Let me submit it for real here. Okay. All right. That's it for today. What is this? Trail of ones. The solution really, I don't know. They listed Bitmagic as one of the topics. I don't know if there is some kind of bit twiddling hack that I'm not aware of. That when you see this, you recognize it and you say, "Oh yeah, I know how to do this." My approach, as you saw, was just let's run some results and see if we can detect a pattern, which we did. We implement the pattern and problem solved. So that's it for today. Like the video, subscribe. You'll get these directly in your inbox. And I will see you next time.